We're going to do a few more of these problems because they're tricky and because I didn't realize at the end of the last video that we have to enter in our own units of k, and I did not show you how to figure out the units of k, which is actually pretty tricky. So we'll do 2 more of these at least. We'll see how it goes. So we are going to label our data 1, 2, and 3, and our goal is to figure out the exponents in our rate law. Rate equals k, n2 to the x, h2 to the y, and we're going to start by solving for n2. So that means that we want to look for 2 sets of data where h2 is a constant. So let's use data set 1 and 3. H2 is going to be a constant, and we're going to set those fractions up. With data set 1, the rate from data set 1 is 0.669, and the rate from data set 3 is 0.145. And that is going to be equal to, for data set 1, k, 2.19 to the x, and 2.08 to the y. And for, whoa, I just changed colors. For data set number 3, it's going to be k times 1.02 to the x and 2.08 to the y. And so we are able to cancel out k, and we are able to cancel out the 2.08 to the y, and that will simplify our terms for us. And we have 0.669 divided by 0.145. That is 4.614, and that is equal to 2.19 divided by 1.02. That is going to be 2.147 to the x. So in the last video I was showing you how to solve this with logs. The log of 4.614 is equal to x times the log of 2.146. That's the correct way. You can also, like I said in the video, you can just start guessing and checking with x. X is going to be, usually it's going to be 0 or 1 or 2. You don't have a lot of choices. And so for this one, if we just do some guessing and checking, I mean, it's got to be 2. So we can say that x is 2, and we can feel pretty confident about that. And we've got one part of our rate law figured out, n squared to the 2. So now let's solve for y. In this one, we want to pick 2 sets of data where n2 is staying constant, and that's going to be data set 1 and data set 2. For data set 1, the rate is 0.669. For data set 2, the rate is 13. And that is going to be equal to k times 2.19 to the x, 2.08 to the y. No explanation for y, just switch to parentheses there, just roll with it. 2.19 to the x for data set 2, and 9.18 to the y. And then we're going to cross off k and 2.19 to the x because we know that those are the same. So we do the math over here, 0.669 divided by 13. That is 0.05146. And on the right-hand side, 2.08 divided by 9.18. 0.2265. To the y. So this data feels goofy to me. I'm looking at it really quick, making sure that I didn't make a mistake. So let's use the log method this time. The log of 0.05146 is equal to y times the log of 0.2265, and solve for y. Log of 0.05146 divided by the log of 0.2265 gives us y equals 2. So now we have our rate law done. And now we're ready to solve for the rate constant K. So we can pick any set of data we want. Let's just pick the first set of data. For that, the rate of the reaction is 0.669 molarity per second. And this is going to be important that we include units this time because we're trying to figure out what the units are as well as trying to figure out the value of K. So that's going to be equal to K times the concentration of N2, 2.19 molarity squared, times the concentration of H2, 2.08 molar squared. And so now we need to solve for K, and we need to include the units when we're solving for K. So I'm just moving these terms over to the left side of the equation. And I'm going to get, first I'm going to do the math, so 0.669 divided by 2.19 squared times 2.08 squared. So the number that I'm getting to 3 sig figs is going to be 0.0322. And let's think about what we've got going on here for units. So our units are going to be, if we just look at the units alone in this fraction here, we have molarity per second over molarity to the fourth, because it's molarity squared. So that is going to be, we can cancel out one of those molarities. Our units are going to be 1 over molarity to the third times second. What? And ALEKS likes it a lot better if you don't put that in a fraction. So molarity to the negative third, second to the negative 1. That is really overwhelming. 0.0322 molarity to the negative third, second to the negative 1. Let's see how I did. I'm going to do this part first. 0.0322 molarity to the negative 3, and then you got to use this little dot guy, second to the negative 1. And our rate was, I'm just going off of memory here. I hope I'm not going to screw this up. It is N2 and H2, and they're both second order. N2, oops, wrong way. Oh, delete that. H2, and they're both second order. Let's see how we did. All right, we'll do one more so you guys can feel really good about doing this. So starting with our rate law, with our data 1 and 2 and 3, we know our rate law is going to be H2 to the something and I2 to the something. And let's start by solving for H2's exponent. So that means we want to find two sets of data where I2 is not changing. So that's going to be data set 1 and data set 2. Data set 1 and data set 2. The rate of the reaction is going to be 0.518 divided by 0.228. That's rate for 1 divided by rate for 2. And that is going to be equal to K times 2.08 to the X, 1.69 to the Y, over, for reaction 2, K times 0.916 to the X, 1.69 to the Y. Cross off our K and our 1.69 to the Y. Do the math on what we have left. 0.518 divided by 0.228. That is 2.272. And on the other side of the equal sign, 2.08 divided by 0.916. That is 2.271. 1 to the x. So we know that our x is a 1. So we've got that part figured out. Now let's move on to solving the exponent for I2. So here we want two data sets where H2 is a constant so that we can focus on I2. And that's going to be data set 1 and data set 3. Our rates are 0.518 divided by 2.22, and that is equal to k times 2.08 x 1.69 y divided by k 2.08 x 7.23 y. What can we cancel out? We can cancel out the k and the 2.08 to the x. And we can do some math. 0.518 divided by 2.22 is 0.2333. And 1.69 divided by 7.23 is also 0.233. So our y is also 1. And like I said in the last problem, I'm pretty sure ALEKS doesn't want the 1s there, so don't put them in there. You don't want to make ALEKS mad. Now let's solve for k, including the exponents. So we're going to use, let's just use data set 1. The rate for data set 1 is 0.518. I said including exponents, but I meant to say including units. 5.18 molarity per second. That is equal to k, which is what we're trying to figure out, times our H2 concentration, which is 2.08 molar, and our I2 concentration, 1.69 molar. So we're going to do the math. We're going to move these 2.08 and 1.69. We're going to move those terms over to the left side. 2.08 molar and 1.69 molar. One of our molarity units will cancel, but only one. 0.518 divided by 2.08 and divided by 1.69. Numerically, we're getting 0.147, and in terms of units, our units are 1 molarity unit down on the bottom and 1 second unit down on the bottom. You guys can totally do this. I believe in you. This is hard, but you can